In the last section, you learned how to build RESTful services using Express. In this section, we're going to continue our journey with Express and look at more advanced topics. More specifically, we'll be looking at middleware, configuration, debugging, templating engines, and more. So now, let's get started. One of the core concepts in Express that you need to learn is the concept of middleware or middleware function. A middleware function is basically a function that takes a request object and either returns a response to the client or passes control to another middleware function. You have already seen two examples of middleware functions. One is this route handler function. So in Express, every route handler function we have is technically a middleware function because it takes a request object and in this case, it returns a response to the client. So it terminates the request response cycle. So this is one example of a middleware function. We have another example that is on line 5. So when we call express.json method, this method returns a function, a middleware function. The job of this middleware function is to read the request, and if there is a JSON object in the body of the request, it will parse the body of the request into a JSON object, and then it will set request.body property. So essentially, this is what happens at runtime. When we receive a request on the server, that request goes through this pipeline. We call this pipeline the request processing pipeline. In this pipeline, we have one or more middleware functions. Each middleware function either terminates the request response cycle by returning a response object, or it will pass control to another middleware function. So in our current implementation, our request processing pipeline has two middleware functions. The first one is the middleware function that parses the request body into a JSON object. Now in this case, it doesn't terminate the request response cycle. So then it passes control to the second middleware function, which is in this case, our route handler. In our route handler, we have the request object with the body property populated. So here we can perform some operation and then terminate the request response cycle by returning a response to the client. So Express includes a few built-in middleware functions, but we can also create custom middleware functions that we can put at the front of our request processing pipeline. So every request that we get on the server will go through our middleware function. With this custom middleware function, we can perform cross-cutting concerns. For example, we can do logging, authentication, authorization, and so on. So an Express application is essentially nothing but a bunch of middleware functions. In the next lecture, I'm going to show you how to create a custom middleware function. So now let me show you how to create a custom middleware function. So here on line 5, we're adding JSON middleware function. After that, we're going to call app.use. Once again, we call this method to install a middleware function in our request processing pipeline. So here we need to pass a function that takes a request, response, and next, which is a reference to the next middleware function in the pipeline. So we simply pass a function here. Now in this function, let's do a simple console.log, logging. Let's imagine this middleware function is for logging every request. So we perform our logging and then we call next to pass control to the next middleware function in the pipeline. If we don't do this, because we are not terminating the request response cycle, our request will end up hanging. Let me show you what happens. So I'm going to comment out this line, save. Now back in Postman, on this tab, I'm going to send a simple HTTP GET request to our courses endpoint. So send, look, we are not getting a response. It's loading. And if you look in the console, you can see our logging message. So this indicates that our middleware function was executed successfully, but because we did not pass control to another middleware function to terminate the request response cycle, our requests end up hanging there. So let's bring this line back in. We can also create another middleware function for performing authentication. So I'm going to select this code, duplicate it, And in this second middleware function, I'm going to change this message to authenticating. Now, back in Postman, let's send another request. Now look in the terminal. We have two messages, logging and authenticating. So what I want you to pay attention to here is that our middleware functions are called in sequence. First, our login middleware function is called, then the middleware function for authenticating the user, and finally, the route handler, which is another middleware function. Now, in terms of clean coding, when you want to create a custom middleware function, you don't want to write all that code inside index.js file or index module. You should put each middleware function in a separate file or a separate module. So back here, let's create a new file called logger.js. Now, back in index.js, let's grab this middleware function here, cut it, and back in logger.js, we paste that here. We give this function a name, like log, and finally export it like this, module.export. We set this to this function. So this module exports a single function, okay? Now, back in index.js, on the top, we load our new module. So period slash to indicate the current folder, and logger. We get the result and store it in a constant called logger. And then we can install it by calling app.use and pass this logger function here. Now you understand exactly what this line means. So when we call express.json, it returns a function, a middleware function that has three parameters: request, response, and next. That middleware function parses the request body, and if there is a JSON object, it will set request.body, and then it will pass control to the next middleware function, okay? So let me delete this comment. Back in index.js, so this is how we define a custom middleware function in a separate module, import it here, and then install it by calling app.use. We could use the same technique for the second middleware function, but I'm going to leave that to you as an exercise. So in the last lecture, you learned how to build custom middleware. But as I told you before, in Express, we have a few built-in middleware functions. One of them is this JSON middleware that now you're familiar with. So it parses the body of the request, and if there is a JSON object, it will populate request.body property. We have another similar middleware function that is called URL encoded. So let me duplicate this line. Here we have express.url encoded. Again, this is a method we call, and what we get in result is a middleware function. This middleware function parses incoming requests with URL encoded payloads. That is a request with body like this. So we have key set to value and another key set to value. Now, this is more of a traditional approach. It's not something that we use that often these days. Basically, if you have an HTML form with input fields and post that form to the server, the body of your request will look like this, okay? So that's where you have URL encoded payload in the body of your request. Now, this middleware parses this body and populates request.body like a JSON object. Let me show you how that works. So back to Postman, let's send a post request to localhost port 3000 API courses, okay? So previously, we passed a JSON object in the body. So I told you to select raw here and then application JSON. However, in this demo, we're going to use form URL encoded here. So now we can pass key value pairs in the body of the request, and they will be concatenated when this request is sent to the server. So the key I'm going to set is name, and the value is my course. Send. Now you can see we successfully created a new course on the server. So our middleware function was able to read our request with URL encoded payload. Now, if you look in the terminal, you see this warning, body parser deprecated, undefined, extended. Provide an extended option. So this warning is telling us that we should pass an object here and set extended to true. With this, we can pass arrays and complex objects using the URL encoded format. Okay. Now, finally, the last built-in middleware function we have in Express is static, and we use that to serve static files. So let me show you how that works. app.use express.static. Now here we pass an argument, and that's the name of a folder. In this case, I'm going to use a folder called public. So we're going to put all our static assets like CSS, images, and so on inside this folder. So let's create this folder here, public. For now, I'm just going to add a simple text file here, readme.txt, and this is a readme file. Okay. Now with this middleware function, we can go back to the browser and head over to localhost port 3000 / readme.txt. So with this middleware, we can serve static content. And note that here we don't have public in the URL. So our static content are served from the root of the site. In the next lecture, we're going to look at third-party middleware. In this lecture, I'm going to introduce you to a couple of third-party middleware we have in Express. So head over to expressjs.com. On the top, under resources, you can find middleware. So these are all the third-party middleware that you can use in your applications. But that doesn't mean that you should use every single middleware function here, because every middleware function will impact the performance of your application. If you don't need the functionality that comes with a middleware function, don't use it. It's just going to slow down your request processing. So spend some time, have a quick look at this documentation and see what is out there for you in case you need it. Now, in this list, the middleware that is considered best practice is Helmet. So it helps you secure your application by setting various HTTP headers. So let's have a quick look here. Basically, all we have to do is load this Helmet module using our require function. What we get here is a function. So we call that, and that returns a middleware function, and then we'll use that. That's all we have to do. If you want to better understand what Helmet does under the hood, you really need to look at the documentation because that's beyond the scope of this course. So back in the terminal, let's install Helmet. Now here in our index module on the top, we load Helmet, get the result and store it in a constant called Helmet. This is a function, so we're going to call that and pass it to app.use method. So Helmet, like this. The other third-party middleware that you might find useful is Morgan. We use Morgan to log HTTP requests. Let me show you how that works. So once again, npm install Morgan. Now here on top of the file, we load Morgan using the require function. Very simple. And then finally, use it like this. So Morgan is a function. Now here you can specify various formats. I'm going to use the simplest one, that is tiny. Again, you need to look at the documentation to see various options that are available to you. So now, back in the terminal, let's run the application. With Morgan in place, every time we send a request to the server, it will be logged. So here I'm going to send a simple GET request to our courses endpoint. Okay, now look at the terminal. Morgan logged our HTTP request. And this is the tiny format. It's very, very simple. So we sent an HTTP GET request to this endpoint. The result was a status code of 200, which means successful. And this is the time it took to respond to this request. So this is the tiny format. If you want more details, you set a different format. And by the way, by default, Morgan logs the request on the console, but you can also configure it to write it to a log file. Again, remember, when you turn on this feature, it will impact your request processing pipeline. So perhaps you may not want to do this in production, or you may want to enable this only in certain situations. For example, you can have a configuration file. When you deploy this application to the production, in certain situations, you can turn this on for a short period of time and then turn it off. In the next lecture, I'm going to show you how to work with different environments such as development, testing, and production. In a more complex or enterprise-like application, you need to know what environment your code is running on. Is this a development environment or a production environment? Perhaps you may want to enable or disable certain features based on the current environment. For example, let's imagine we want to enable logging of HTTP requests only in the development environment, on a development machine, but not in production. So let me show you how to do this. Earlier, you learned about this process object. This is a global object in Node that gives us access to the current process. This process object has a property called env, which gives us the environment variables. Now, we have a standard environment variable called node_env. And this environment variable returns the environment for this node application. If it's not set, here we're going to get undefined. Alternatively, we can set this from the outside. We can set this to development, to testing, to staging, or production. So for this demo, let's log this on the console. So console.log, I'm going to use the backtick character to define a template string. Node_env is $, curly braces, and here's our process.env.node_env. Now we have another way to get the current environment, and that is via the app object. So this app object has a method called get that we use to get various settings about this application. Now, one of the settings is env. This method internally uses this environment variable to detect the current environment. However, if this environment variable is not set, this will return development by default. Let me show you how that works. So console.log, backtick, the label is app, and here we add $ with curly braces, and then app.get of env. Now back in terminal, look, our environment variable is not set, so that's undefined. But app.get is returning development by default. Okay, so this is the difference. Now, which approach to choose is purely your personal preference. Now, in this demo, we want to enable logging of HTTP requests only on a development machine. So we can write code like this. If app.get env is development, then we're going to enable Morgan. And also for debugging, I'm going to display something on the console. So Morgan enabled. Okay, now let's delete these two lines. We don't need them anymore. Back in the terminal, because this is my development machine, you can see Morgan is enabled. Now let's stop this process, set the environment variable to production, run the application again, and then you will see that Morgan will not be enabled. So stop this process with Control and C. We set our environment variable using export on Mac or set on Windows. So node_env, we set this to production. Now let's run the application one more time. So nodemon index. Okay, look, we only get this message, listening on port 3000. We don't have Morgan enabled. So this is how you can tell if your code is running on a development, testing, staging, or a production machine. So in the last lecture, you learned how to detect the environment in which your application is running. One topic that goes hand in hand with environments is the topic of storing configuration settings for the application and overriding those settings in each environment. For example, in your development environment, you're going to use a different database or mail server. So in this lecture, I'm going to show you how to store configuration settings for your application and overwrite them in each environment. Now, there are various node packages out there for managing configuration. The most popular one is RC. So if you look up npm rc, look at the second link here, npmjs.com/package/rc. So you can see this package has been downloaded over 11 million times over the past month. It's a very popular package, but I personally haven't been very happy with this package. I've noticed a number of issues. That's why my personal preference is another package that is not as popular, but it has a very clean and elegant design, and it's really easy to use. So look up npm config. Again, look at the second link here, npmjs.com/package/config. So this package has been downloaded over 600,000 times over the last month. But it has a very active community. There are quite a few collaborators in this project, and I find it a better solution to manage the configuration of your applications. So back in the terminal, let's install the config module. Beautiful. Now back in the project. Here, let's create a folder called config. In this folder, we can have a default configuration file. So let's add a new file called default.json. So here we can have a JSON object to define the default configuration settings. For example, let's have a setting here called name. That's the name of our application. Now, back in the configuration folder, let's add another file, development.json. In this file, we can define the settings specific to the development environment. As part of this, we can override the settings that we defined in default.json. We can also add additional settings. So here I can change the name. I can override it saying my Express app development. We can also add additional properties here. And these properties can also be complex objects. For example, we can have a property called mail, where we store information about our mail server. So here we can have host, and let's set this to development mail server. Similarly, we can create another configuration file called production. So production.json. Now I'm going to go back in development.json, copy all this, paste it in production, and then change the name of the application as well as the address of the mail server. So prod mail server. So with this node package, you can easily see the default configuration as well as the configuration for each environment. It's very clean. It gives you a very clean structure. Now, back in our index.js, on the top, we load the config module and store it in a constant called config. And with this, we can easily get various settings for our application. So let's look at a few examples. Configuration. I'm going to do a console.log application name. Now here we could use a template string. That doesn't really matter. The way we use this config object is like this. So it has a get method. And here as an argument, we specify the name of a configuration property. So name. Now let's duplicate this. The other property I want to display is mail server. For this, we need to access this setting here, host, which is part of mail. The way we do this is using the dot notation, just like accessing properties of an object. So we want to get mail.host. Okay. Now back in terminal, I'm going to put this machine in the development environment. So export node_env. We set this to development. and then run our application. So you can see application name is set to My Express App Development. This setting is coming from our development.json file. Similarly, our mail server is dev mail server. Okay. Now, if we change the environment to production, we're going to see different values. So export node _env, we set this to production and run the application one more time. Look, this time our mail server is prod mail server. So with this node package, you can easily store the configuration settings for your application. However, you should not store the application secrets in these configuration files. For example, you should not store the password of your database or your mail server, because when you check in your source code to a repository, that password or that secret is visible to anyone who has access to that source control repository. In fact, one of the famous financial companies in the US was hacked because someone checked in a password into source control repository. So the way we deal with these secrets is by storing them in environment variables. Let me show you how that works. So back in terminal, let's define an environment variable for storing the password of a mail server. So export password, we set it to 1234. Now, to prevent this environment variable to clash with another environment variable, it's better to prefix that with the name of our application. Now, in this demo, let's say the name of our application is app. So we add app underline as a prefix. Okay. So in development environment, we manually set this environment variable. And also in production environment, we'll most likely have a configuration panel for storing our environment variables. So we store all these passwords and secrets in our environment variables and then read them using our config module. Now back in the project, in the configuration folder, we need to add another file called custom-environment-variables. Make sure to spell it properly. The name of this file is very important. So custom-environment-variables.json. And in this file, we define the mapping of configuration settings to environment variables. So I'm going to go in our development.json file, copy all this into this new file. Now let's say here for the mail property, inside that we're going to have a property called password. Okay, so we want to map this to the environment variable that we created. That was app underline password. Okay. Now we don't need host because we are not going to map this to an environment variable. The value is defined in one of our configuration files. Delete. And for the same reason, we don't need name. So in this file, custom environment variables, we only have the mapping of our configuration settings to environment variables. Now back in index.js, let's duplicate this line and display the password of the mail server. So mail password. And we get that from mail.password property. So this config object looks at various sources to find a value for this configuration. The source can be a configuration file, a JSON file. It can be an environment variable. It can also be a command line argument. For that, you need to look at the documentation yourself. Now, back in terminal, let's run the application. Okay, look, our mail password is 1234, and this was read from an environment variable, not a configuration file. Again, this config package has a lot of useful features, and I leave it up to you to read the documentation and learn more about this package. Earlier in this section, we wrote this code to see if we're in the development environment. If yes, we enabled Morgan to log the HTTP requests, and we also log this message on the console. So this console.log is JavaScript programmers' oldest friend. We use it all the time for debugging. The problem with this approach, however, is that sometimes when we are done with them, we delete them or comment them out, but sometime later, we may need them, so we have to write the code again or remove the comment. This approach is very tedious. A better way to log messages for the purpose of debugging is to use the debug package in Node. With debug, we're going to replace all these console.log statements with a call to a debug function, and then we can use an environment variable to enable or disable debugging. This way, we don't have to come back to our code and modify the code. We don't have to delete these console.log or debug statements. We don't have to comment them out. We can control them from the outside using an environment variable. But more importantly, we can also determine the level of debugging information we want to see. Maybe sometime we're working on a database problem. Perhaps we only want to see the debugging information related to the database. So again, we don't have to come back to the code and modify all these console.log statements. So let me show you how to use the debug package. Back in the terminal, let's install debug. Beautiful. Now this is telling me that there is a newer version of NPM available. It just got released perhaps a minute ago. So it's suggesting me to update it, but I'm not going to do that because I want the course to be consistent with the version that I installed at the beginning. Now, back to our index module on the top, let's load the debug module. This require function here returns a function. So we call this function and give it an argument. And this argument is an arbitrary namespace that we define for debugging. For example, we can define a namespace like app:startup. Now, when we call this function with this argument, we get a function for writing debugging messages in this namespace. So let's call that function startup debugger. Startup debugger. Potentially, we can have another debugger for debugging database related messages. So once again, we load the debug module. We get a function. We call that function, give it a namespace like app::db, and this will return a debugging function. So we get it and store it in db debugger. Okay. Now here on line 9, we're going to replace this console.log statement with a call to startup debugger function. So startup debugger, like that. Now potentially somewhere in the application we can have some database work, and there we may need to write some debugging information. So we can use our other debugger function, so db debugger, connected to the database. Something like that. Now we're going back to the terminal and use an environment variable to determine what kind of debugging information we want to see in the console. So here we set an environment variable called debug. We set this to app::startup. That means with this, we're going to see only the debugging messages that are part of this namespace, app::startup. Now, if you run the application, look, we got app startup, and here is our message. Now, next time I run this application, maybe I don't want to see any debugging information. So we can reset this environment variable to nothing, run the application again. Look, we no longer see this debugging message. Or we may want to see debugging messages for multiple namespaces. So we can set our environment variable to app::startup, app::db. With this, we will see the debugging messages in these two namespaces. Or if you want to see all the debugging messages for our app namespace, we can use a wildcard. This way we don't have to repeat each of them individually. Now when we run the application, look, we see the messages in different namespaces. So app startup and app::db. And the beautiful thing about this debug module is that it color codes the namespace. So we can easily distinguish the various debugging messages. We don't get that with console.log. Now there is also a faster way to set the level of debugging we want to see. So we don't have to explicitly set the environment variable using the export command. We can set the environment variable at the time of running our application. So let me clear the console. Let's say this time I only want to see debugging messages in app:/db namespace. So we said debug, set it to app:/db, now space, run our application either with node or nodemon. So this is a shortcut to set an environment variable, in this case debug, and run the application at the same time. And one last thing, in this particular demo, I created two debugging functions, startup and db debugger. But in a real world scenario, you may not necessarily need multiple debugging functions in the same file or in the same module. If that's the case, you can simplify your code by changing the name of this debugger function to debug. For example, in this file, let's say we don't have any database work. So I'm going to delete this. We only want to write debugging messages about the application startup. So let's delete this db debugger function. And now we can rename this function startup debugger to debug. So look, that's shorter than writing console.log. And it gives us a lot more power and control over how much of the debugging information we want to see. So prefer the debug module to console.log statements. In all the endpoints we have implemented so far, we return JSON objects in the response. Sometimes, however, you need to return HTML markup to the client, and that's where you use a templating engine. There are various templating engines available for Express applications. The most popular ones are Pug, which used to be called Jade. You also have Mustache and EJS. Each templating engine has a different syntax for generating dynamic HTML and returning it to the client. So in this demo, I'm going to show you how to use Pug to generate a dynamic HTML and return it to the client. So first, let's install Pug. Beautiful. Now, back in our index module, we need to set the view engine for the application. So we call app.set. The name of the property we need to set is view space engine, and the name of our view engine or templating engine is Pug. So when we set this, Express will internally load this module. So we don't have to require it, okay? Now there is another setting that is not compulsory, it's optional, only if you want to override the path to your templates. So app.set, the name of the property is views, and the value is the path to where we store the templates. So the default value is /views. That means you should put all your views or all your templates inside a folder called views, which should be in the root of the application, right? Again, this is an optional setting. That's the default value, so we don't have to set that. Now, let's add a new folder here, views. Inside this folder, let's add a new file. We can call it index.pug. With Pug, we can define our template using a syntax like this. So we can have an HTML element. Then inside that, we can have head. Then we can have the title element, and we can set a value for this dynamically using the syntax. So we add an equal sign and then the name of a variable that we will set at runtime. I will show you how that works later. Now, in parallel to head, we want to have another element called body. And inside that, we want to have an h1. And we want to set the value for this dynamically using a variable called message. So you see, Pug has a cleaner syntax than regular HTML. We don't have those opening and closing elements. Of course, some people love it, some people hate it. But that aside, let's see how we can convert this to regular HTML and return it to the client. So back in our index module, earlier we defined a route for the root of the application. So here we send a simple message to the client, hello world, right? Now we want to replace this with an HTML markup and return it to the client. So instead of the send method, we use render. So response.render. Now as the first argument, we specify the name of our view. In that case, index, because the name of our file is index.pug. As the second argument, we pass an object, And this object includes all the values for the parameters that we have defined in our template, like title and message. So here I'm going to set two properties, title, my Express app, and message, hello. That's all we have to do. So now let's start the application again and head over to localhost port 3000. Look, we get HTML markup. We can verify that by looking at the source of this page. What you see here is our Pug template converted to standard HTML. So we have HTML, head, title. This value is inserted dynamically at runtime. And then next to that, we have body. And inside this, we have this H1 element. So if you want to return HTML markup to the client, you use a view engine. Again, there are various view engines available like Pug, EJS, Mustache, and so on. But when you're building RESTful services for the backend of your client applications, you don't really need a view engine or a templating engine. I just covered this topic because I wanted my Node course to be comprehensive. Next, I'm going to talk about database integration. All right, we got to database integration. Actually, we have a separate section about this topic where I will teach you in detail how to work with a MongoDB database. But in this lecture, I just want to point out what are various database integration options available for you when you use Node and Express. So on Express website, if you go to Guide and then Database Integration, on this page, you can see various database drivers that are available for you to use. You can use Cassandra, Couchbase, MySQL, Mongo, Oracle, Redis, SQL Server, Elasticsearch, and so on. So there are various options available here. For each of these, you can see some sample code. So let's have a look at MongoDB. Basically, what you need to do is to install the driver for working with Mongo. So npm install MongoDB. And then you load that using the require function. Then you will get a simple API to connect to Mongo. And then you can access various collections and so on. Working with other databases is the same. You install a driver, and then you get a module with a simple API. Now, in case of Mongo specifically, there is another package that is called Mongoose, which is built on top of Mongo client, on top of this MongoDB package. So instead of using the Mongo driver directly, we use Mongoose because it gives us a simpler API. Again, later in the course, we're going to have a comprehensive section about working with Mongo and Mongoose. So far we have covered a lot of ground about Express. But what about authentication? Well, authentication is outside the scope of Express because Express is a minimal, lightweight framework and it doesn't have an opinion about authentication. So later in the course, we're going to have a comprehensive section about authentication and authorization. So I will show you how to secure your API endpoints. So this is the code we have written in index.js throughout this section. If you look, here we have a very big file with 92 lines of code. And this is a very simple application. In the real world application, you don't want to write all that code inside index.js. So in this lecture, I'm going to show you how to properly structure your application. The first thing we want to do is to take out all the code for this courses API and put it into a separate file. In other words, for every logical part of our application, for every API endpoint, we want to have a separate file or a separate module. So all the routes for working with courses should be in courses.js, and all the routes for working with, let's say, authors should be in authors.js. So in the root of the project, let's create a new folder, call it routes. Here we add a new file, courses.js. Now, back in index.js, let's select all the code for working with courses. Now, cut, back in courses, paste it here. Now, back in index.js, you can see here, we only have 40 lines. But first, let's finish refactoring the courses routes. So, back to courses.js. On the top, first we need to load Express. So, constant express, we require it like this. Now in index.js, we called express as a function and we got an app object, right? But this approach does not work when you separate the routes in a separate module. So here we need to use a router. So this express has a method called router that returns a router object. Now here I'm going to rename this app to router for clarity. So press F2, router. So the difference is that in this module, in courses module, instead of working with the app object, we work with the router object. Okay. Now finally, at the end of this module, we export this router. So module that exports, we set it to this router. So in summary, we get the router on the top, we add routes to it, and finally export the router at the end of the module. Okay. Now we need to load this courses module inside index module. So back in index.js, here let's load the courses module. So require current folder / courses. Now we get this and store it in a constant called courses. And finally, once we load this module, we need to call app.use. Here we need to supply two arguments. The first argument is a path. So /API/courses. And the second argument is our router object that we imported, that is courses. Basically, we're telling Express that for any routes that start with /API/courses, use this router, the router that we loaded from the courses module. And with this, we can go back to our courses module and make our routes a little bit shorter. So back to the courses module on the top. See, every route here has this part /API/courses. We don't want to repeat this everywhere because in index.js, we told Express that any routes that start with /API/courses should be handled by this courses router. So back in the courses module, we can get rid of all these /API/courses. So for the first route, which is for getting all the courses, our route will change to just a /. Same for the second route. For the third route, we have a parameter, so we'll only add /:id. Similarly, for the delete route, we only need /:id. And finally, the same for the last route here. So you can see our routes are much simpler now. Now back in index.js, I forgot to move the definition of our courses array into our courses module. So cut. Now back in courses module, on the top, here's our courses array. And that means our index module is now even shorter. It's only 37 lines of code. Now here's a simple exercise for you. I want you to refactor this route to the home page and put it in a separate file. So pause the video, do this exercise, and then you can come back, continue watching. All right, so here's what we need to do. Here in the routes folder, I'm going to add a new file. Let's call this home.js. First, we load Express. So require Express. Then we get a router. So router is express.router. Now back in the index.js, we get this route, cut, and paste it here. But instead of app, we attach it to this router. And finally, we export the router. So module that exports, we set it to this router. And finally, we go back to index.js and load this new module. So on the top, here's where we loaded our courses module. Let's load the home module. So require /home. Actually, I noticed that I made a mistake. So the actual path to this module should be routes/courses. Same here. Now finally, here where we are adding the middleware, we call app.use. We say for any path that starts with slash, use the home router. All right, now if you look at index.js, all we have here is simply the startup code for our application. Now, one last thing before we finish this lecture. So earlier, we created this logger middleware. We put it in a separate module, and we exported this function at the end of this module, right? Now, in terms of structuring your application, it is possible that you might have multiple middleware functions. So it's better to put them all in a folder called middleware. So here in the root of the application, we create another folder called middleware and move this logger inside this folder. Move. And this also means we should go back to index.js. On the top, where we load this middleware, we should change the path to /middleware/logger. All right, now it's time for an exercise. So this is the Vidly application that we have built so far. Currently, all the routes for working with genres are defined in index.js. What I want you to do is to refactor this application and move all these routes inside a new folder called routes. There you should have a file called genres.js. So move all these routes there, add them to a router object, export the router, and then import it into index.js. So pause the video, do this exercise, and when you're done, come back and continue watching. All right, so first, I'm going to add a new folder called routes. Inside this folder, I'm going to add a new file, genres.js. Now back in index.js, I'm going to move all the code for working with genres into our new module. So starting from our genres array all the way to the end of this validate genre function. Cut, back in genres, paste it here. Now on the top, we need to load the express module, store it here in this constant, and from here we get a router. So constant router, we set it to express.router. Now here, because we're working with the app object, it's easier to temporarily call this app and then rename all this together to router. Next, we need to simplify our routes and get rid of /API/genres. So our get and post routes should be like this. Next, we have our put route. So here we only need /:id. Next is delete. That should be the same. You only need /:id. And finally, for the get route, the same. So we're done with simplifying our route. Now at the end of this file, we need to export this router. So module.export, we set it to the router. And finally, we need to import this router in our index module. So back in the index.js, on the top, we import genres. That is in the routes folder. And finally, we call app.use. We tell Express for any routes that start with /API/genres, use the genres router. As simple as that. Now our application has a cleaner and more maintainable structure.